Predictive regression is a class of machine learning techniques that predict specific numbers. In this video, we want to see general principles for evaluating the quality of the performance of a predictive regression model. So in general, the goal of predictive regression is to minimize the error. And the error is understood as the difference between the actual true values and the predicted value that the model gave. So the error is generally how far the prediction was off. For example, if the true value was 89, but the prediction was 70, then the error is an error of minus 19. The primary statistic used to evaluate prediction quality is the root mean squared error. Mathematically, it takes all the errors, squares each of them, adds all the squares together, takes the average, takes the square root of that. And one of the main characteristics of the RMSE to understand is that it penalizes large errors disproportionately more harshly than smaller errors. In other words, it says that if you're off by 15, well, that's worse than if you're off by only 3. And so it will give you much worse penalty for being off larger than for smaller. And a lot of the times this makes sense, but one case where it is probably not the best to use is where you have a lot of outliers. And when you decide that you're not going to remove those outliers, but the outliers mean something that you want to retain in your data set, then the RMSE penalizes outliers very steeply and might inflate the true indication of how perhaps the majority of your data points were more accurately predicted. One advantage of the RMSE is that it is in the same unit as the unit of the target label. So if you're measuring, let's say, counts of customers who come into your store, where it's 200 or 300 or 400, and your RMSE is maybe 15, then that represents 15 customers off. So it's easy to interpret in that way. Another popular measure is the mean absolute error, or MAE. In RapidMiner, this is called the absolute error. And this is similar to the RMSE, except that instead of squaring the errors and then taking the square root, it just takes the absolute value. That is, it removes the sign, and then it adds them all up and then averages them. The main difference with the RMSE is that it penalizes errors proportionally to how large they are. So being off by 15, okay, it's worse than being off by 3, but it's only 5 times worse. It's not going to be exponentially worse as the RMSE would have penalized it. So similar to RMSE, it is in the same unit as a unit of the target label. So that gives easier interpretation. Generally speaking, if being farther off is really bad for you and you want to penalize a model more for that, you use RMSE. But if how far off it is, it's proportional. You don't want to disproportionately penalize those that are farther off, then the MAE would be more appropriate. I'd also like to talk about some popular measures, which are quite often used, but perhaps are not as useful for evaluating regression in the context of predictive analytics. First, the R squared, or the squared correlation, as it's called in RapidMiner, is a very popular technique. In fact, it's the most popular in statistical modeling. But statistical modeling is different from predictive analytics. So in statistical modeling, you're trying to look at the fit for the existing data. And in that case, the R square really captures the variation in the entire data set. But for predictive analytics, you're trying to estimate the error in the future data sets simulated by usually the test validation. And for that, R square does not make much sense. RMSE and MAE are much more appropriate measures in that case. Another popular measure is the mean average percentage error, MAPE, also called the relative error. And it expresses changes in percentage units, where 100% is the average size of the target label. And the intention is that because it's always on a 100% scale, it's supposedly comparable across data sets. And so no matter what you're measuring, 100% is about the same. But statistically, it has a lot of inconsistent properties. It doesn't grow equally or so on. So it's really best to avoid this measure completely. Now, when you have multiple models, like say a linear regression model with some settings, a linear regression model with some other settings, maybe a regression tree and a neural network, and they're all trying to compare them, how do you compare which is the better model? So in general, first, looking at each model on its own to see if the model alone is good, you need some sort of benchmark. And the naive benchmark, when you consider if a model is good, is generally the standard deviation of the target variable. Without getting to the statistical formulas, the standard deviation represents the natural variation in the data set. So you might have prices, for instance, and maybe the average price is 10,000, but you can say it goes up or down by maybe 1 or 2,000. And it has particular meanings, like if you say the standard deviation is 2,000, you can say that around 2/3 of the data is going to be from 8,000 to 12,000 if it's normally distributed and all that. But that standard deviation represents a natural variation in the data. And so the RMSE formula is actually quite similar, quite analogical to, or quite analogous to the standard deviation. And so generally speaking, an RMSE, that is the error of the predictive model, should be less than the natural range of error in the data set. So a good RMSE should be less than the standard deviation because you're trying to minimize error. The MAE, mean absolute error, is mathematically smaller than the RMSE always when calculating the same data set. And so the standard deviation is also a suitable benchmark. The MAE should also be smaller than the standard deviation. But remember, this is for regression models that predict specific numbers. For classification, when you have categorical predictions, the benchmark is the prevalence or frequency of the modal category in the dataset. Now, when you're comparing multiple models, suppose they all beat the benchmark, they're all better than standard deviation, then simply the best model is the one with the lowest error score, whether RMSE or MAE. And it's as simple as that. Now, each of these should be better than standard deviation, or you're not even talking about a good model. But when you have multiple models, the lowest error is the best. And that's these are the basic principles of evaluating the predictive regression models.